Okay, so welcome back. And now let's talk about the next five problems. Number 6. At the given point, find the slope of the curve, the line that is tangent to the curve, or the line that is normal to the curve, as requested. Okay. So in this places, I assume that it just asks us to figure out the tangent. Okay, the tangent. So that's number 6. Y6 plus x cubed equals y squared plus 11x, and the slope at 1. Okay, so basically this problem tells us to figure out the dy dx using the implicit differentiation, and then evaluate at this specific point. So if I do that, I'm going to have is take the differentials, right? So dy6 dx plus dx cubed dx equals dy squared dx plus 11 dx dx. And then we can simplify. So 6y 5 times dy dx plus 3x squared, right? Plus I equals 2y dy dx, and then plus actually 11, right? So we're looking for this dy dx here, so that is 6y 5 dy dx minus 2y dy dx, right? Equals 11 minus 3x squared. Okay. So I just group all the terms with dy dx to the left and all the rest to the right hand side. So now factor this dy dx out. So we have 6y 5 minus 2y dy dx equals 11 minus 3x squared. So dy dx equals 11 minus 3x squared over 6y minus 2. Okay, so this is our dy dx, and we're looking for the slope, right, at this specific point, 0, 1. So all we need to do is the slope at point 0, 1. It's dy dx evaluated as 0, 1, which x is 0, y is 1. So you're going to have 11 minus 3 times 0 squared, right, over 6 minus 2, right? That is 11 over 4. That's the slope. So if you go back and then starting to look at our answer, 11 over 4, the answer is going to be B. Okay. All right. So that's number 6. Number 7. Number 7 should be easy. So find the derivative, right, with respect to x. So y equals ln of 6x, right? So for this, the derivative is 1 over 6 times the derivative of 6x. So it gives us 6 over 6x. That is 1 over x. In fact, guys, y equals ln of ax. The derivative is always 1 over x. Okay? You can verify that part. So that's number 7. That's pretty easy. Now let's move on to look at the last 3 problems. Okay, so number 8 and 9. 8 and 9, it asks us to use the logarithmic differentiation to find the derivative of y. Okay, so it has the requirement to use the logarithmic, right? So let's see, how do we apply the logarithmic? The thing is, even we don't use the logarithmic, so you can see for number 8, we can apply the product rule first and then to take the derivative, right? Same logic. For number 9, we can also, distribute it and then just to take the derivative. But now let's see how we can apply the logarithmic differentiation to figure it out, because it's a different approach. In those two problems, yes, the alternative way are easier, okay? But for some other problems, use logarithmic differentiation can be like really handy, and then can be very effective. Okay, so now let me show you this. Y equals cosine x times square root of 3x plus 8. So number 8, y equals cosine x plus 8. What you'll do here is we take the natural logarithm on both sides. And apparently, when we take the natural logarithm on the right-hand side, based on the property of the logarithmic, this is what I can have. Even more, for this guy, we can rewrite it as this: 3x plus 8 to the power half, and then bring half into the front. So that gives us here. Of course, left-hand side is still long y. Okay. And now we're gonna apply implicit differentiation. Okay, so in other words, take the derivative with respect to x on both sides. So on the left-hand side, you're going to have 1 over y times dy dx. On the right-hand side, so you're going to have 1 over cosine x times the derivative of cosine x, which gives you negative sine x. Okay. And then plus half times the derivative of this is 1 over 3x plus 8 times the derivative of 3x plus 8, which we know that 8 is 3. Okay. So now you can see, so this is negative 10x, right? Plus 3 over 2 times 3x plus 8. And then, since we are looking for this dy dx, right? So we're almost there, right? So dy dx equals negative 10x plus 3 over 2 times y. But what is my y, right? Well, don't forget y is this guy. So that is your answer through the logarithmic differentiation. Okay, so that's number 8. And the derivative of ln y with respect to x is always 1 over y times dy dx. So to go back, trying to see what we want. So it turns out, so we'll see that C is what we want. Okay. Number 9, almost there, right? So number 9 is y equals x minus 6, x plus 3. And so if we apply natural logarithm, on the right hand side, oops, right, so that's based on the property of natural logarithm. And then we take the derivative with respect to x. That's 1 over y dy dx equals the derivative of this guy is 1 over x. Derivative of this guy is 1 over x minus 6 times the derivative of x minus 6, which is 1, plus 1 over x plus 3 times the derivative of x plus 3, which is also 1. So, dy dx equals and then remember it's multiplied by y, right? What is my y? It's right here. It's x minus 6, x plus 3. So that's how do you get the derivative through the logarithmic differentiation. So let's look at that, and then apparently this, right? This is the one. So that's number 9. Number 10 should be easy, right? So number 10 is y equals ln of 4x squared. So the derivative 1 over 4x squared times the derivative of 4x squared, which is 8x. Turns out you're going to have 2 over x, right? 2 over x. And then that's it. So, okay. So that's everything I want to share with you. So thank you for watching.